This conference will now be recorded.
Personal Hdfs, what is Hadoop and its history, what are Hadoop core components and Hadoop daemons. So let's get started. So first one is what are the sources of big data? So if you talk about this term called sources, the meaning of source is nothing but where is this big data coming from? Right now we are in 2018 and we are using internet everywhere on the mobile phones, on the laptop, on the desktop, everywhere. So if you see this is coming from very famous social networking website called Facebook. It's saying that 973,000 logins are being happening every minute. Again, it's coming from Google. It's saying that 3.7 million queries are being searched. This is again coming from WhatsApp. It's saying that 38 million messages are being transferred. Similar is the case with Instagram, and many apps are being downloaded from Play Stores, and 4.3 million videos are being watched on YouTube. So because of the staggering numbers, we can say that we have got a huge amount of data. That's what is called big data. The actual definition of big data is it's nothing but huge amount of data which cannot be stored or processed by the traditional RDBMS system. So I had to remember this term called which cannot be stored. And interestingly, 90% of the data has been generated the past few years. This is the memory capacity conversion chart we have got, and it's saying that 1 byte is 8 bits, 1 KB is 1024 bytes, and 1 MB is 1024 KB, 1 GB is 1024 MB, and 1 TB is 1024 GB, and so on. So when can we say that we have a big data problem? When the data that is getting generated is going beyond your TBs, then we can say that we have got big data problem. Okay, now let us see what are the characteristics or the categories of big data. So there are generally three categories of big data. One is structured data, other one is unstructured data, third one is semi-structured data. If we talk about this first one called structured data, as the name indicates, it will have proper structure available. So it will have proper structure in the form of rows as well as columns. So RDBMS table can be taken example for structured data. And if we talk about the next one, unstructured data, these days everybody have their own CC cams installed in the offices and the homes, and that must be generating huge amount of data on minute basis. So videos can be taken as example for unstructured data, and similarly audio is another example for uh, unstructured data. Similarly, a lot of mails are being transferred that also can be considered as unstructured data. We talk about the last one, which is semi-structured data. This semi-structured data might include this XML as well as JSON. So these two can be considered as example for semi-structured data. So these are generally three categories of data. Just remember this. Then let's move on and see what are the characteristics or three V's of big data. Generally it, there are three V's. Let's talk about the first three, which is nothing but variety. Okay. So generally these comes under the variety. If you take any of these, we have just talked about three categories. It would fall in one of those. Okay, and variety is nothing but different forms of data that's being generated. If we talk about next V, which is nothing but velocity. Velocity is nothing but the speed at which the data is being generated. And these days we have Facebook accounts, and then we are logging into Facebook and then posting something on hourly basis, daily basis, and weekly basis. So velocity is nothing but, in short, amount of data that is being generated. And let's talk about the last way, which is nothing but the volume. Volume is nothing but the size of the data that is being generated. It could be in MBs or GBs or TBs or PBs. So, in a nutshell, big data is a combination of all these three V's put together. Then we can say that we have got big data problem. Okay. Now, these days, people generally mix up these terms called big data and Hadoop, and they use it synonymously, but they are not synonyms. They are actually different. So, big data is different and Hadoop is different. Big data is a problem that we have got. Just problem is inverse, there must be a solution. So, the solution for our big data problem is nothing but Hadoop. So, in a nutshell, big data is the problem, whereas Hadoop is a solution that we have got to deal with big data problem. Let's talk about what are the disadvantages of RDBMS and then advantages of Hadoop over it.
Hey,
So,
Vamsi.
yeah, tell me, Abbas.
Yeah, there's seems to be a lot of static coming in the background whenever you speak.
Is there some background noise coming up?
Yeah, static, like static. I can hear it. Whenever it only happens when you speak. Do you think we should try to reconnect again just now?
Hmm, okay, okay. Let me
Let's
reconnect again then.
let's
Okay,
try because it's
okay.
I can hear.
Let's rejoin then.
Let's rejoin. Yes.
Okay.
Okay. Hey, Vamsi, can you
Boss,
hear
can you
me?
hear me?
Yes, much better. Hello. Hey,
Hello,
Vamsi, can you
Boss,
can you
can you
hear
hear
me?
me?
Yeah, I can hear you. Can you hear me? Hello.
Hello, Boss, can you hear me?
Yeah, I can hear you.
Okay, cool. Uh, Somehow I have to get a permission to share my screen. Can you talk something? I cannot hear you completely. Can you talk
Hello.
something?
Hello. Testing, testing, testing. Hello.
Okay. So there seems to be some connectivity issues again. Yeah, can you retry connecting it again? Because I'm not able to hear you at all. Okay.
Hey, Vamsi, can you hear me? Hello.
No, I cannot hear you. Can you talk something?
I am. Can you hear me? Hello. Testing.
Oh, okay. Looks like some problem from my end as well. Let me give it a try again. Hello, Abbas. Can you hear me?
Yes, I can hear you fine.
I think it's audible now, right?
Yes.
Okay, cool. But I cannot share the screen because I have to get a permission from them. Okay, give me a minute again. No other option.
Okay.
Yeah, Abbas, can I start from the beginning or shall we continue from wherever
No,
we
no,
were?
no, no. Let's continue where we left off.
Okay, okay. I think anyways the session was being recorded. I think looks like okay, right?
Yes, yes,
Okay. Okay, we'll continue from here itself. So,
yes.
we were talking about the disadvantages of traditional RDBMSs and advantages of Hadoop over traditional RDBMS. So, we'll talk about in parameter wise. So, first parameter is storage limit. So, if you take traditional RDBMSs, there are some storage limit constraints because of which we won't be able to store huge amount of data and then process it. But if you take Hadoop, we can store huge amount of data. And if you talk about next parameter, varieties, only the structured data can be stored on processed using traditional RDBMS. Whereas with Hadoop, we can store on process structured data, semi-structured data, and unstructured data. And if we talk about the next parameter, which is cost of the software, if you want to work with traditional RDBMS based software, you'll have to buy a license software by paying huge amount of money. And not only that, you have to renew your license of the software every few years in order to work on it continuously. Whereas coming to Hadoop, there is no cost at all. The software is absolutely free of cost. And let's talk about processing type. I've got a huge population and have a database called world's population, out of which I want to retrieve the citizens who are living in the country called US now. Okay, that is going to take a lot of time by traditional RDBMS because the reason is it is going to make use of serial processing or the sequential processing that would have a lot of performance impacts. Whereas if we talk about Hadoop, no, it will actually do sequential processing or not sequential. It will do parallel processing or distributed processing where it will be distributing the data onto the different data nodes and then it will be processing it. So that we'll be talking about in detail shortly. And cost of the hardware. In order to work on traditional RDBMSs, you need to have high-end servers in order to make things happen. Whereas coming to Hadoop, you can even make use of any commodity hardware as well to work on it. Last parameter is source code. Uh, even if you don't like any feature, or if you're facing stability issues or slowness in the traditional RDBMS software that you're using, we don't have any other option but to wait until the next release comes, right? So, but whereas coming to Hadoop, if it's absolutely open source. What do you mean by open source? We can absolutely download the code of Hadoop and then we can play with it. You can customize it. You can modify it as per your need, and then you can move on. So these are some of the parameters using which we can say that Hadoop is a clear winner over traditional RDBMS. Let's talk about the history of Hadoop. Now, Doug Cutting is the founder of Hadoop. When Doug Cutting was working in Google way back in 2003, Google was facing this issue of storage issue because it was not able to cope up with the large number of millions of queries that are being searched by the users. So that's when Doug Cutting pitched in and then he published a paper in 2003 such as GFS, which stands for Google File System. And it eventually spanned into other paper called to MapReduce in 2004, which is nothing but the processing layer. So MapReduce will actually do the processing of this data that's stored in Google File System. And this name Hadoop interestingly came because of his son's toy elephant's name is also Hadoop. So that's when looking at his son's toy elephant name is Hadoop. That's when he named it as Hadoop. So that's why you would be seeing a small elephant everywhere wherever you see Hadoop. Now let's talk about what is Hadoop. It actually came as a source project, open source project from Apache Software Foundation. Basically, it's a framework to do the distributing the data and as well as processing the data that's stored in the clusters of servers. Again, what we mean by clusters is nothing but group of machines or computers connected together. And it actually came as inspiration from GFS Google File System as well as its MapReduce programming model. It was actually a sub project of net Sachin project, but because of its popularity and then when they're cutting more from Hadoop Google organization to Yahoo organization, it actually became open source and then it's completely written in Java. But as Hadoop admins, we don't need to worry about learning a programming language such as Java. So Linux basics are good enough to move on. So coming back to what is Hadoop, it efficiently processes large volumes of data on clusters of commodity hardware, which is nothing but group of machines which are made up of commodity hardware. And we have seen already how to make a setup on single machine by using Cloudera QuickStart And going forward, we'll be making how to make Hadoop setup on clusters of machines, which is nothing but again group of machines connected together. And it can even be spanned or scaled from single machines to thousand nodes. Node is again nothing but computer or machine on the fly. What do you mean on the fly? Even we can add a machine or you can delete a machine without having any business impact or without having any downtime as if nothing has happened. So that's the meaning of on the fly. Now let's talk about Hadoop ecosystem components. So these are the some of the ecosystem components of Hadoop that we'll be learning. So we'll be learning about Hdfs, which is nothing but the storage component of Hadoop. This stands for, then we'll be talking about Yarn or MapReduce, which is a resource management tool. And then there are a lot of other processing tools such as Pig, which is based on scripting mechanism. It's a processing tool. Again, Hive, which is based on SQL, which is again processing tool. Similar is the case with Naut, which is based on machine learning. And then we have got Uzi, which is a workflow tool. And then we have got data exchange tools such as Scoop and as well as Plume, which is a log control mechanism, and we have got HBase, which is a columnar database. So I'll just briefly explain, and finally we have got this Zookeeper also, which is a coordinator. And I'll just briefly explain you the flow involved in general Hadoop-based projects. These are nothing but data ingestion tools. This Scoop and Flume are considered as data ingestion tools. What do you mean by data ingestion? Data ingestion is nothing but inputting the data or extracting the data from the traditional RDBMS such as MySQL. And then after extracting the data, we'll be storing it onto Hdfs. So once the data is stored on Hdfs, we would be processing it using either Pig or Hive. And then once the data is processed, then we would be updating that processed data either onto HBase or we will be again exporting it back to MySQL. And these are Uzi and Zookeeper will actually uh, kind of coordinator tools. They'll help us in performing all these things. So that's the brief overview of how generally these Hadoop projects work. Okay, I hope you got some clarity, but we will move on and then we'll see about each of these components in detail in our future sessions. So let's move on and see. So before going ahead, I have an interesting story for you, the king and minister story, where there lived a king in a kingdom. On one fine day, he wanted to find out how many people are living in his kingdom. That's when he called his minister to find out number of people living in the kingdom. King minister just obeyed king's orders and then he went away. He went alone and then he found out the count, but he came back after 10 days. Though king is getting to know the count, king is not happy because the reason is he is getting to know the count after 10 days, which is a very long time. That's when king suggested to minister to take help from other soldiers as well. That's when minister took help from other soldiers also. This time he came back to king within very short time. King is absolutely happy because he's getting to know the count in very short period of time. See, if you compare this first approach where minister was working alone to find out the count, this is kind of sequential processing model. This is what is happening in the traditional RDBMS. It's based on sequential serial processing, which is making a lot of performance impacts. If you talk about the second approach where minister was taking help from all the other soldiers also, that is considered as the distributed or parallel processing mechanism, which is the base for our Hadoop. Okay, even in our Hadoop architecture also is based upon similar model of master-slave architecture and distributed storage distributed processing mechanism. So even our Hadoop architecture contains master, which can be considered as king, and as well as slaves, which are nothing but ministers on all the other soldiers. Okay, and it's based on distributed storage and distributed processing mechanism, because we will be distributing the data onto the different data nodes or slave nodes. Whenever I use a term called master node or master, it is nothing but a computer. And whenever I use a term called local data node or slave node, it is also nothing but a computer. Okay, so our Hadoop architecture is based on master slave architecture. Okay, and as well as distributed storage and distributed processing mechanism. Abbas, any doubts till now?
No, we're good.
Okay, cool. So, this master is considered as name node NN, and this secondary master is considered as secondary name node. And whereas the slaves are called as data nodes or worker nodes. Just remember these terms. We will be using these going forward. So let's talk about Hadoop core components. There are two Hadoop core components. One is Hdfs and then the other one is MapReduce. Hdfs stands for Hadoop Distributed File System. It's a storage layer because this is the place where we store all our big data. And whereas MapReduce is the processing layer, it will be processing the data that's stored on Hdfs. So in a nutshell, Hadoop is a combination of two core components. One is Hdfs, and then the other one is MapReduce. Let's talk in brief about each of these components. So our first one is Hdfs, which stands for Hadoop Distributed File System. So as the name indicates, we'll be distributing all our data onto the different data nodes, and then we'll be processing it. Then we will see going forward in next 2 to 3 slides how it is considered as fault tolerant. And then SDFS stores multiple copies of data. You have to remember this term again, multiple copies. It won't deal with single copy, it will be dealing with multiple copies onto the different data nodes or different worker nodes. As well as we have a situation where we have a huge file, and then we split up or we break up that file into small pieces. Each small piece is called block, and then we will be storing each of that block onto the multiple data nodes. Again, multiple data nodes, that to multiple copies of each block. These two things go hand in hand, multiple data nodes as well as multiple copies of each block. And then we have got different versions of Hadoop. We have got Hadoop 1.x and Hadoop 2.x. And then the block size is 64 MB in Hadoop 1.x, and whereas the block size is 128 MB in Hadoop 2.x. And the next thing is Hadoop cluster, which is nothing but a a group of machines connected together again. Even in our Hadoop clusters also, it's a combination of single name node as well as combination of multiple data nodes put together to form HDFS cluster. Now let's talk about how to create blocks in HDFS. I have this file which is of size 260 MB, and imagine that I'm using Hadoop 2.x. What is the default block size? 128 MB in Hadoop 2.x. So I would be our task is to find out how many blocks this file would be divided into. So as the default block size is 128 MB, I will be dividing 260 MB by 128 MB, which will give me 2 point something. So it's pretty clear that there will be two full blocks. What do you mean a full block? So default block size is 128 MB, right? So that's what I meant when I was talking about full block. So it would create two full blocks of 128 MB. If you add these two, it will be 256 MB. If you minus that, 260 MB minus 256 MB, so it is going to create a third block which is of size 4 MB. So totally there will be three blocks created, two blocks of 128 MB and third block of 4 MB. So this is how you generally create blocks in HDFS. Now let's see how HDFS is fault tolerant. Imagine that I have this large file and I broke it into small pieces. Each small piece is called block. Then I have got four blocks, B1, B2, B3, B4. Then I have distributed onto the different data nodes, other slave nodes on my cluster. After distributing it, I want to process it. In order to process this large file, I need all the four blocks, B1, B2, B3, B4. And what did I say? So we will be distributing these blocks into multiple copies. So I have B2 here, I have B2 here, I have B3 here, I have B3 here. And then I have got B4 here, I have got B4 here. But in order to process this large file, I need all the four blocks. So I need block B1 also. But one fine day on the data node on which this block B1 is there has gone down. you still don't need to worry because we have got B1 stored as the copy on the different data node. So that's what when I mean fault tolerance. We were still in a position to process this large file without having any downtime or without having any business impact, as if nothing has happened, even though one of the data node on which this block given is there has gone down. So that's what is called fault tolerance. Let's talk about in brief about our another core component called MapReduce. So MapReduce is the processing layer of Hadoop where it will be doing the work by parallelly dividing the work into different independent tasks. So it's a distributed processing mechanism where we'll be processing the data that is stored on the clusters of nodes. Let's let me show you pictorially. I have to process that large file again. I need four blocks: B1, B2, B3, B4. For that sake, I wrote a MapReduce program, and then I have submitted that MapReduce program to master. So this master is completely aware of what is stored where. So in order to process that large file, I need all the four blocks. So this master is completely aware. So these blocks B1, B2, B3, B4 are stored on so and so data nodes, and master is completely aware of the IP addresses of all those data nodes as well. That's when this master is going to copy that code only onto the data nodes where these blocks are available. It won't copy to every data node. It will copy only to the nodes where these B1, B2, B3, B4 are available. So that's how we generally do the processing in MapReduce. So, in order to summarize, it involves four steps basically: step one, two, three, and four. Step one and two can be considered as part of Hdfs. Three and four can be considered as part of MapReduce. The first step will be breaking our input data into small pieces of blocks, and uh, size could be either 64 MB or 120 MB based on the version that we use. Then we would be moving all those blocks onto different data nodes. Then once we store it, then we will be processing it with the help of MapReduce program. So then it's up to the master to process it, and then it will be writing output back to the Hdfs. Let's talk about what are the different daemons available in Hadoop 1.x. Before going ahead, let's talk about this term called daemons. Daemon is nothing but a process that will be running continuously. If you take your Windows operating system, whenever you log in, there will be something called Task Manager that will be running continuously. So it will be running continuously as soon as you switch on your laptop, it will run continuously until you shut down your laptop. So Task Manager is considered as an example for daemon process. Similarly, we have got five daemon process or five daemons in Hadoop 1.x as well. So three in Hadoop, three in HDFS, two in MapReduce. So if you talk about daemons in HDFS, we have got three daemons: name node as the master, and slave daemon is data node, and we have got another daemon in the form of secondary name node. So totally three daemons in HDFS and two daemons. One is job tracker. This is the master in MapReduce, and then we have got task tracker, which is the slave in MapReduce. So totally five daemons together in Hadoop 1.x. So this is the simple architecture of Hadoop 1.x. We have got name node here, and then we have got all the data nodes, and then we have got secondary name node situated here. So we'll talk about this architecture going forward at a greater details. So this is how generally the location of all these daemons will be. We will have this task tracker and data node running together on the same machine, and we'll have this job tracker and the name node running on the same machine because these are the masters and these are all the slaves. So job tracker will be in touch with the task trackers, and whereas this name node will be in touch with the all the data nodes. So this is how the placement of the daemons happens in Hadoop 1.x architecture. Now let's talk about this. So we have seen that total there are five daemons, and out of which in HDFS the master is name node, and whereas the slave is considered as data node or the worker node. Similarly, in MapReduce, which is the processing layer, we have got master as job tracker, and whereas the slave is nothing but task tracker. Now we'll go ahead and talk about each of these daemons at a greater detail. Our first daemon is name node, which is nothing but the master node of HDFS. The main purpose of name node is to store the metadata of the file. So metadata of the file system. So if you take the dictionary meaning of metadata, metadata is considered as data about data. So this metadata includes what are the file locations in HDFS, file ownership, file permissions, file timestamp, file sizes, file replication factor, individual blocks, and location of each of these blocks on the different data nodes. So these all details include metadata. And the main purpose of name node, as we have discussed, is maintaining the metadata. This metadata will be stored on the disk, and it is actually read whenever the name node daemon starts up. So the file that we use for maintaining the metadata is nothing but fs image. It's an image file, and then all the changes to the metadata are made in RAM. The changes are written to a log file called edit log file. So we'll talk about fs image and edit log at greater detail in the future sessions. So you have to remember that name node is the first point of contact for all the HDFS operations. So that's why it is called single point of failure, because the reason is if this name node goes down, your complete cluster goes down. So that's why it is called as single point of failure. So this is how it will be. So we have got name node here, and then we have got all the data nodes here. So name node actually keeps track of where data blocks is stored for a particular file on which data node. And data nodes are the actual nodes which store the actual data, and then they return the data based upon the request from the name node. And let's talk about the next daemon, which is nothing but data node. It is considered as slave node or slave daemon in HDFS layer, which is the storage layer. This is the daemon, or this is the node which actually stores the data. It stores the data in the form of blocks based on the instructions from name node. And name node and data node will communicate via heartbeat mechanism. So data node will be sending heartbeat signal to the name node every 3 seconds, uh, which is meant to say that I'm working fine, I'm alive. So that's the meaning of this heartbeat. So if the name node doesn't receive this heartbeat signal for 10 minutes, then it is going to mark the data node as dead. So this could be one of the interview question. So what is the communication mechanism between data node and name node? The answer is heartbeat mechanism. So using heartbeat mechanism, the data node and name node communicates together. So every 3 seconds, this data node is going to send a heartbeat signal to the name node. If the heartbeat signal is not being received by the name node for 10 minutes, then it is going to mark that particular data node as dead, and then it is going to move all the blocks that are stored on the data node to some other alive data node. Let's talk about our next daemon for today, which is nothing but secondary name node. People just confuse, and then there is a misconception that they just think that this is the backup for the name node, but this is not the backup for name node. So that's what I'm saying. It's not a failure over name node. It is not going to take over name node's responsibility if it goes to the failure state. It is a kind of helper node which will actually do this process of retrieving the fs image and edit logs from the name nodes and perform checkpoint mechanism at regular intervals of time. So this checkpointing is nothing but retrieving the fs image and edit log from the name node, and then it is going to create a and it is going to merge that fs image and edit log. It is going to create a new fs image, which is nothing but checkpointing mechanism. So if you don't understand these terms, especially, you don't need to worry much, because we are going to talk completely about these terms going forward. Okay, that's about secondary name node. Let's talk about the next uh, which is nothing but job tracker. Job tracker is considered as master node, master daemon in MapReduce layer or map processing layer. So it runs on the same machine as that of the name node, and any MapReduce job or program that is submitted to will actually be get in touch with job tracker. So this is the first point of contact for the MapReduce jobs. And Basically, job tracker checks for the locations of various file blocks used in MapReduce programming. Then it initiates separate tasks on various data nodes where the blocks are available with the help of task tracker daemons that are running on the different data nodes. So job tracker is considered as master in processing layer. And task tracker, let's talk about next daemon, which is nothing but task tracker. Task tracker is considered as slave daemon in processing layer. Basically, there will be multiple task trackers running on your cluster, whereas there will be single job tracker that will be running on the same data node. Whereas we have multiple instances of task tracker running on the same data nodes as well. So it is going to receive the information from the job tracker, and it is going to initiate the tasks with the help of the task tracker. This task tracker again makes use of map tasks and reduce tasks in order to do the processing. That we'll be talking at greater detail when we talk about map reduce job submission part. Again, task tracker and job tracker will make use of this heartbeat mechanism in order to communicate with each other. Again, it is going to check for the heartbeat signal for every 3 seconds. If it is not going to receive the heartbeat signal, job tracker is going to mark that particular task tracker as dead. Okay, let's talk about Hdfs blocks. We know that is large file is divided into small pieces. Each small piece is called block in HDFS. By default, the replication factor is 3. So this could be one of the interview questions. So what is the default replication factor for each and every block? The answer is 3. The meaning of it is it is going to replicate it. Replicate means it is going to create a copy of each of the block. Three. It is going to make 3 copies or 3 replicas of each of the block, and it is going to store on the different data nodes. And remember, the blocks are never replicated on the same data node. Okay, and by default the block size is 64 MB in Hadoop 1.x, and the block size is Hadoop 128 MB, 128 MB in Hadoop 2.x, and it's a configurable one. So there are some configuration files that are available in order to change this block size that we'll be seeing at later point of time. So again, I took a simple example. I have this 150 MB input file. Then I want to break this file into small pieces. So imagine that I'm using Hadoop 1.x architecture, and then default block size is 64 MB. So that's when it is going to create totally 3 blocks. One block of size 64 MB, second block of size 64 MB. If you add these two, the leftover one will be 22 MB. So it is going to create totally 3 blocks, out of which 2 blocks of 64 MB, 64 MB, and then the uh, third block will be of 22 MB. So this is going to create totally 3 blocks. Okay, and you know, today I wanted to keep it a bit short because the reason is this could have an overwhelming impact on you, because once you are clear with these terms, tomorrow we'll be talking about HDFS commands. So this will be a
Right.
summary for our summary for today, and we have seen HDFS, which is the storage layer of Hadoop, and we have seen MapReduce, which is the processing layer of Hadoop, and we have seen that the master is name node in HDFS, and as well as slave is data node or the worker node in HDFS. Okay, and similarly we have seen the job tracker is the master, and then the task tracker is the slave daemon in MapReduce, which is nothing but the processing layer. And also I have got some of the interview questions for you based on the topics that I have covered today. So I would suggest you to finish off every day's concept on the day itself, so that that won't have any pending going forward. So these are some of the interview questions which you can try answering it on your own, and I'll be sending the answers as well in a separate document, so you can validate your answers by looking at it. So I have put totally 10 questions based on the topics that we have covered today. So if you can refer the recording of this, so it will be in a good position to answer all of these 10 entry questions. Okay, so I hope, Abbas, you have completed the practice of Linux, right? Linux and shell scripting. If you
Yes.
have any doubts, are there any doubts in Linux and shell scripting part?
Well,
No,
I'm
right?
still practicing because I got fell behind because of my sickness, but I'm recovering. But I
Mm-hmm.
will be reaching out to you, Vamsi, when I get stuck with any of it. I'm still practicing right now.
Yeah, yeah, you're
Uh,
always welcome. So you're always welcome. So if you have any queries or when you are stuck with something, you can just contact me on my WhatsApp. So I'll be getting
okay.
in touch with you.
Actually, Vamsi,
So, but
what time are we meeting tomorrow? Sorry about today. I was confused about today because I thought you
hey,
said
no problem, no problem. Not an issue at all. So we'll be meeting at 6 a.m. IST every day, and then it will go for 1.5 hours from tomorrow. So
okay,
please plan accordingly. So it's going to be 6 a.m. to 7:30 a.m. from tomorrow onwards. Okay,
no
please
problem.
plan accordingly, and also try to finish off the Linux commands because that will be base for you. Okay, for going forward. So
Okay,
try to finish off, and then I wanted to keep it short today so that you can finish off the pending tasks by today, and then you can come up fresh tomorrow.
okay, okay. Sounds good.
Okay, let's meet 6 a.m. to 7:30 a.m. from tomorrow onwards. Okay,
Okay, sounds good. Thank you.
see you
Thank
then. Bye bye.
you. Bye bye.